Hello everyone, my name is Edward Marin, a graduate school student of Davao del Norte State College, taking up Master of Science teaching mathematics. And this morning, we will be discussing about exploring Euclidean geometry in a triangle. So let's go to the introduction first. Euclidean geometry did not end with Euclid. Over the years, since he wrote the elements, many people have worked to extend his works and have proved an incredibly large number of fascinating and surprising results, especially in the 19th century. The study of Euclidean geometry is more depth understanding are found in numerous sources like those in the book of Ives, Dodge, and Posamentier. So let's go first with this definition. Definition 7.7.1. Okay? So three lines are concurrent if there is P such that P lies on all three of the lines. The point P is called the point of concurrency. Three segments are concurrent if they have interior point in common. So what have you observed with the figure? If you have observed the figure, there are three lines, namely line L, line M, and line N. And they intersect at one point, and that is point P. So by just looking at the definition, concurrent lines are lines that intersect at one point, or they have a common point. So, line M, and line N are concurrent lines. And point P is the point of concurrency. Next, let's move on to the median for the triangle. So what have you observed with the figure? So we have triangle A, B, and C. And we have created median AD to connect to the opposite side, BC. Then we also have median BE to connect to its opposite side, AC. And the median CF to connect into the opposite sides, AB. So remember the definition that a median for a triangle is a segment joining a vertex of the triangle to the midpoint of the opposite side. So, when we talk about midpoint, it is a point that divides the segment into two equal parts. So, this is how we created our median for triangle ABC. And we have here the fact that the three medians are concurrent, and the point of concurrency of the three medians is called the centroid of the triangle. So, we have also here the fact that the centroid divides all the three medians in the ratio of 2:1. So, if you have observed that segment AD, segment BE, and segment CF are intersecting lines, and they are also called concurrent lines, and they intersect at point G. So point G now is the centroid of the triangle. Okay? And look at here, the centroid divides all the medians in the ratio of 2:1. If we're going to measure AD, so the measurement of AD will be divided into three parts, and this is 1:2. Okay? Next, we have here the altitude for the triangle. So by definition, an altitude for a triangle is a line through one vertex that is perpendicular to the line determined by the other two vertices. So look at here the figures. So we have triangle A, B, C. So if we're going to create the altitude, so it must be, this line must be perpendicular to that line. For example, AC. So the altitude is H, and this is supposed to be D. So HD is the altitude of AC. Next, CH there you have it. Okay? If you're going to extend AB, then this CH will be the altitude of this line. And if we're going to extend BC here, so this AH will be the altitude of this line. So, we have here the three altitudes of the triangle are all concurrent, and the point of concurrency is called the orthocenter of the triangle. Okay, next we have here, okay, fact. First, a centroid is always inside the triangle. That is a fact. Second, an orthocenter can either be inside, outside, or in the sides of the triangle. That is also another fact. So we have here two figures. So, this is to compare the centroid and the orthocenter of different triangles. Okay, next we have circumcenter, A circumcenter of the triangle is the point of concurrency of the three perpendicular bisectors of the triangle. So O in the given figure, O is the circumcenter. So if you have observed that D is perpendicular bisector of BC. Why is it called perpendicular bisector? Because it is perpendicular to BC. At the same time, it divides BC into two equal parts. Okay? E is the perpendicular bisector of AC. And F is the perpendicular bisector of AB. And if you're going to look at the figure, the three perpendicular bisectors meet at one point, and that is called circumcenter. Okay, so let's proceed with Theorem 7.7.3. It is called the Euler line theorem. Some other books or some other mathematicians would say it is Euler. So Euler line theorem, whatever. The orthocenter H, the circumcenter O, and the centroid G of any triangle are collinear. So let us try to prove this statement as Theorem 7.7.3. So we have here the same triangles. This is the centroid of triangle G, and this is the orthocenter of the triangle, and this is the circumcenter of the triangle. So if you have observed, we're going to connect that one or overlap that one. So you can discover that the three are collinear. So it means that they are in the same line. Okay? Unless the triangle is equilateral, in which case the 3 points coincide, and H equals 2GO. So you have observed here the equilateral triangle. All the three are on the same point, or we can locate in the same point. Okay, so we have here a medial triangle. A medial triangle is a triangle associated with the median concurrence theorem. So triangle DEF is the medial triangle of triangle ABC. The medians of the two triangles are concurrent at their centroids. So how did we create the medial triangle? So first is we have to look for the midpoints of the line. The midpoints of AB, BC, and AC. From that midpoint, we connect the midpoints and we created the second triangle DEF, and that is the medial triangle. So if we are going to draw the medians of the triangle, if you have observed, they just overlap. So the medians are just concurrent and collinear. Okay, next we have an orthic triangle. An orthic triangle is associated with the orthocenter of the triangle. So we have here triangle DEF is the orthic triangle of triangle ABC. The altitude of the two triangles are concurrent in the orthocenter of the triangle. So before we created DEF, so we look for the altitude of the triangle. And from that altitude, that point, we connect the lines, and that makes triangle DEF. Okay? And actually we still have two theorems to discuss, but it will be discussed by my classmate in master's degree, Ma'am Salam. So thank you for watching and have a good day.